Alright, this is shear and moment equations and diagrams. So let's say we had a beam. On this side, we had a distributed load, and that length is A. We had a pinned connection over here, so we've got our reactionary forces, AY and AX. Then at point B, we've got a load P. And then at this end, we had a roller such that there is a vertical force. And the whole length of this beam is L. So we've learned that how to find the shear force and the moment, the bending moment inside the beam. But we were looking at just one point. And really when you are designing a beam, you need to know the maximum stresses and forces and how it changes. So basically what we're doing here is learning how to look at this as a whole and plot the entire shear force through the whole beam or the entire bending moment. So the shear force, we make a shear versus X diagram so that we have the shear force over the entire length of the beam. So this one would look something like this. This goes out to A. Then from there we have the same shear force, and then at P there's going to be a discontinuity in the graph. We go back up at L. And we'll go over actually how to do this, but this would be an example of what it should look like. That's point B. So now we could do the same thing for the moment. It's going to go like that to A. Then from A to B, be a straight line up. And then from B down to L. Just like that. So let's look at the procedure of how to do this. Okay, so the first thing you want to do is find your support reactions. And that is, you want to determine your support reactions, and couple moments. Next, we need to write our shear and moment functions. So the first thing you need to do is specify separate coordinates. X having an origin at the beam's left end, and extending to regions of the beam between concentrated forces and or couple moments, or where a distributed load is continuous. Which basically means, as you can see from the graph that we made up here, from 0 to A, there's a function for the shear force. From A to B, there's another function, and from B to L. So basically what we did is we put this beam into 3 separate segments. From 0 to A is one function for both V and M, and then from A to B is another function for both V and M, and then finally from B to L is a third function. So that's what it's saying. You need to look at them as discrete chunks in between your concentrated forces, your distributed loads, and any couple moments. So next we would section the beam. At each distance x, and draw the free body diagram of one of the segments. Oops. And you want to always show V and M in the positive. So basically what we do, you would draw from 0 to A a free body diagram, and in that and you would find V as a function of x right there. Then you would do the same thing. You would draw it from 0 to L, from 0 to B, and then you would have a function for V and M in that section, and just so on and so forth to each of your segments. Okay, and then finally, you would have find your shear and moment diagram. So you want to plot the shear diagram which is V versus X, and the moment diagram, M versus X. So if you had positive V or M values, it's shown above the x-axis, and if you had negative values, it gets shown below. So if this is V or M, any positive values are going to be up here, and any negative values will be down here. Alright, and we'll have an example to follow.